Hello everyone, welcome to Tut-aid. Myself Praveen Kushwaha, and today we will be continuing the first chapter of the class 10th mathematics for board preparation. And we already discussed about the LCM and the HCF, and now we will be discussing about the irrational numbers. So first we would like to understand how and in what way we can find out the numbers that if it is rational or an irrational number. So first we will be basically finding the difference between the numbers. Yeah. So now rational numbers. If we talk about the definitions, the numbers that are in the form of p over q and in which q is not equals to 0, those numbers are called the rational numbers, and the only criteria is p can be 0, but it is not possible that we can get the value of q to be equals to 0, as if it is so then it will not be a rational number. We already know whenever we have to divide a number, for example if we take 2 and we have to divide it by 0, then it will always be a infinite number, so that is what we are not going to consider as any other kind. Okay, let's talk about irrational number because that is something we want to know. So now irrational numbers, we can simply write the numbers in the form of p by q, but whenever a number we convert this p by q into the decimal form. Okay, so in the decimal formation, when we are dividing a number, we get two or three kind of answers. Like if we are doing the division, so first possibility is like if it is 0.025 and the answer is over. The second criteria that is possible is we will get on doing the division and it will not terminate it at all, like it will be 0.12345867274 and so on. And the third one will be 0.121212112 and 12 and so on. So both of the all the three are of different time, and these can be found out by getting any of the rational number converting into the decimal forms. So as you can see, the first and the third ones, they are having a pattern that follows. Like in the first one, it is a terminating number. Terminating. An example is 0.025. It can be any number. If it is 0.5, then it is also a terminating number. But if we are taking the example of the second one, then we can see that it is not terminating, and what is the uniqueness, that it is not repeating at all. And in the third one, it is also not terminating, but in this case it is repeating. So if you remember that you studied in the ninth class, that we can convert this number which is terminating and non-repeating, we can simply convert it easily into the p by q form, and similarly the first one we can also easily convert it into the p by q form, but the third one, that is somewhat difficult to be converted into the p by q form, because we don't know that up to which place it is going to be solved and how many zeros are we going to put it into the denominator, or the method that we use to convert the repeating numbers into the decimal form, that is also not possible here to use them. Okay, so this defines that this is the one which is something unique, and that is what we call the irrational number. Irrational number. So for these irrational numbers, now we will be finding out some properties, or we will be doing some of a bit of calculations that we can get the some special qualities, we will be finding it out. Okay, now for non-terminating, as we took the example that if it is a rational number which when converted into the decimal form, then it becomes a non-terminating, and then we will call it a irrational number. Similarly, there are some other numbers that are possible which we can easily convert into decimals, and they would also represent some decimal numbers which are non-terminating and non-repeating, and these numbers are called the irrational numbers. Like if we want to find the value of root 2, then it is 1.414 and so on. It is not terminating, so that is what we call a irrational number. Similarly, if we want to find the value of root 3, that is 1.732, that is also a kind of a irrational number because it is not terminating and it is not repeating at all. Okay, so that is what we call the irrational number. Before we would move further to find out what will be the proof that we can say that if it is a rational or a irrational number, but before that we need to understand what is the fundamental theorem of arithmetics. Fundamental theorem of arithmetics. Okay, fundamental theorem of arithmetics says that a number can be represented in the form of product of prime numbers. Let's take an example, like if it is 125, or okay, or if we take another example like 110, then we can easily solve it. If we solve 125 by doing the prime factorization using the division method, so 125 will be divided by 5, so it will go 25 times, and again dividing by 5 it will go 5 times and 5 1. So we can see that 5, which is a prime number, and we can write 125 in the form of multiple of prime numbers. Similarly, we want to do the prime factorization, what we call prime factorization it is, so we can divide the number 102. We will start with the smallest number, that is 2. So 2, it will go 55 times, then it cannot be divided by 2. We will think of 3, 4, then we see that 5 is the number which which can divide 55 11 times. Then the next number that is possible is 11, because 11 is already a prime number, so that will be 1. So we can write it as 2 into 5 into 11. And if the number is like 23, it is already a prime number, so we can say that it will be 1 into 23, because these are the only factor, but we generally do not represent 1 while we do the prime factorization, so we can simply ignore this and we can say that 23 will be the prime factor for the given number 23. So this is the way we will do the calculation. Now this is the way that we can find the prime factors of any of the number, or we can say that we can represent a number into the form of multiple of prime numbers. So now what basically the fundamental theorem of arithmetic says? Arithmetic Fundamental theorem of arithmetic says that if a number is given, like if a number, let us say p is a number which is given, and p, if p is divisible by a, then p square is also divisible by a. Okay, so this is a way we are going to understand the actual fundamental theorem of arithmetics, that it is commonly understood like if any of the number p which is divisible by a, then p square will also be divisible by a. Oh, that will be a small a. Let's take an example. For example, if the number is 20 and 20 is divisible by a, and for a let's take if it is 5, so 20 is divisible by 5 and that will result to 4. So similarly, if we want to find out the value of p square, so that will be 20 into 20, which is 400. So 400 will also be divisible by a, which we considered as 5. So yes, we can check that and we will get result is 80. So now by this we can say, now we will be moving to the actual fundamental theorem of arithmetics, and that is if p square is divisible by a, then p is also divisible by A. And that is the property that we are going to use, which we will use to find out that if a number is irrational or a rational number. Okay, so let's take an example and find out. The solution is quite easy and you have to learn it as it is. I'll try to make it short so that you can easily understand. Okay, so now irrational numbers, let's take root 2 and we have to prove it irrational number. Prove it irrational, right? So what we are going to do, we are considering it now, we will be solving it using the algebraical terms. So what we will do, we will say let root 2 be equal to a rational number represented by p over q. And what will be the speciality between p and q? And we will write p and q are co-prime. So I think you know what what the term co-prime means. Co-prime are the number which do not have any common factor, or we can say co-prime are the number which have HCF as 1. So I'm writing it down so that you can easily understand. P and Q does not have a common factor. So from here the solution starts. Now we will say that root 2 will be equals to P by Q. So what we are going to do, we will simply rearrange it. Q will be shifted to the numerator side. So that is a simple method that we do if the term is in the denominator and when we are moving from the border. Okay, so we can say that equal to is the sign of the border. So whenever it is going from crossing the border, so the term which is dividing, it will be multiplied to the other side. So now it becomes P is equals to root 2 times Q. Now what we will do, we will simply square both sides. You can write as it is in the solution when you are doing the solution in your notebooks. So now it will be p square, that is equals to 2q square, or we can say that p square divided by q will be equals to q square. So by this it is defined that if p square is divisible by 2, by this we can say that p square is divided by 2, so that we can, so we are getting q square. So by the fundamental theorem of arithmetics, if p square is divisible by 2, then p is also divisible by 2. Okay, so that is what we discussed in the previous previous page we discussed. So p square is divisible by 2, then p is also divisible by 2. And now what we will say, that if p is divisible by 2, I'm explaining it to you, then in the next solution I will show you the exact solution what we are going to do. So now if p is divisible by 2, then let p over 2 is equals to r. Now what happens, p is equals to 2r, we simply rearrange it and shift this 2 to the other side. Then what we are going to do, we will do the same thing again, is squaring both sides. So now what happens, now it becomes p square is equals to 2r whole square, then p square will be equals to 4r square. And on the previous slide if you see, p square was equivalent to 2q square, so we will mark it first. Now from first p square is equals to 2q square, so we will put p square is equals to 2q square in equation second, and we will mark it this at equation second. So it will become 2q square is equals to 4r square. We will move this 2 to the other side, so it will be q square is equals to 4r square over 2. Then it will become q square is equals to 2r square. Now again what we will do, we will simply rearrange it and it becomes q square is equals to q square over 2 is equals to r square. Now again by the same property, by fundamental theorem of arithmetics, it will be if q square is divisible by 2, then q is also divisible by 2. Therefore both p and q are divisible by 2. As you can see here, q square is divisible by 2 by fundamental theorem of arithmetics. We can say that q is divisible by 2, and on the previous slide we already got it that p square is divisible by 2, then p is also divisible by 2. So what happens now? As we can see, p and q both are divisible by 2. This contradicts the fact, contradict means किसी भी चीज को झुटला देना, which makes that the so thing that we are trying to solve, now it has been totally become opposite of what we were trying to get. So this contradicts the fact that p and q are co-prime. So the condition that we took in the starting that ये दोनों के दोनों numbers जो है वो co-prime है, वो चीज़ यहाँ पर गलत हो गई, and this contradiction arises. Contradiction. अगर contradiction क्यों हुआ? Because we considered root 2 to be rational. हमने root 2 का rational मान लिया था, that is why this contradiction arise. So therefore we can say root 2 is a irrational number. So this is the exact solution that we will do. Now let's take another example and I'll tell you what exactly the lines that we are going to write, and we will try to write a solution in the minimum number of lines that are possible. Okay, so let's take here. Now let us prove that root 7 is irrational. We will do all the steps one by one and try to write all the minimum things that are required. So first take, let root 7 is rational number, and root 7 is equals to p by q. Then in the next line, squaring both sides. You can write all the short forms that are possible. Not every term can be made short, but yes, few of the terms that are quite understandable that we can write in the same form. Then now squaring both the sides, it will become 7 is equals to p square over q square. Then we will rearrange it, or p square is equals to 7 q square. If you want, you can do the rearrangement first and then do the square. It doesn't matter, it will be the same thing. So now what happens, p square over 7 is equals to q square. In this way, then what we will do, we can use the fundamental theorem by fundamental theorem of arithmetics. If p square is divisible by 7, then p is divisible by 7. Therefore let p by 7 is equals to r. So now what happens, we will write it on the same page so that you can easily note it down and understand. So it becomes P is equals to 7R. Then again doing the same thing, squaring both sides. So it becomes P square is equals to 49R square. I'm not writing down which equation is going to be the first one, which equation is going to be the second one, because it is quite difficult to identify that which part we are going to use. We can mark it later as at the time when we are going to use it. Okay, so that is what I wanted to show you, that how we can write the solution even if it is a bit difficult for you to find out. So now you can see that P, we need the value of P square, and we find out the value of P square here. So P square is equals to 7Q square, we will simply mark it. So now, and we will mark it second, and you can see both the values are for equivalent to P square. So we will write equate equation 1 and 2. So it will be 7Q square, that is equals to 49R square. When we will solve it out, we can directly write it. 7 will cancel out it to 7 times, so Q square is equals to 7R square. Okay, that is the way we can do it directly while doing the solution. But if you want to see the elaborated form how we will get Q square is equals to 7R square, then you can see the solution of the previous question that we did in the explanatory form. And in this part we are doing the exact solution that we can write in the board examination. So now Q square is equals to 7R square, and again by rearranging it, we get Q square when divided by 7 is equals to R square. So by this, so we can say Q square is divisible by 7, and by fundamental theorem of arithmetics, if Q square is divisible by 7, then Q is also divisible by 7. Now the same problem arises, then that P is divisible by 7 and Q is also divisible by 7. And what we would consider that P and Q are co-prime. Oh, I forgot to write it, so we will write it here. P and Q are co-prime. So we will write it here. So now, so what happens here? This contradicts that P and Q are co-prime, and this arises due to a wrong assumption, wrong, wrong assumption that root 7 is rational. So we will say therefore root 7 is irrational. So that is what we all are going to do, and this is the exact solution that we will do. Now there is another criteria that comes into the examination, and that says if 2 plus or 2 minus, whatever it is, 2 plus minus root 3, let us say, is irrational. That is the easiest of these solutions. So what we will do, we will simply try to solve it, and let us say 2 minus root 3 it was. Okay, let us consider it 2 minus root 3. Then we will find out that what will be the result while we will do the calculation, how we are going to prove it that it will be equals to a rational number. So now let us say let 2 minus root 3 is irrational. So now what happens? Oh sorry, 2 minus root 3 is rational. Now in this case, let us again say 2 minus root 3 is equivalent to P over Q. Then we are going to simply rearrange it and only leave the irrational part, that is root 3, on the other side. So what will happen here is we are shifting root 3 to the other side. So it will be 2 minus p over q, that is equals to root 3. We shifted root 3 to the other side and p by q to the other side. So this is the way we made root 3 as positive. So now any arithmetic operation of rational number results to give a rational number. So 2 minus p by q will be rational. Now what the problem is, this will be rational but it is coming equal to root 3, and now root 3 is irrational. So what happens is this contradicts that root 3 is irrational. So by this criteria we find out that root 3 will be equivalent to a rational number. Okay, and again this contradiction arises because we considered 2 minus root 3 to be rational. Therefore 2 minus root 3 will be irrational. Okay, so by that we also find out, we can simply make a note of that. So what will be the note? When we do the calculation of irrational numbers, we will simply get the result as irrational numbers. So we can write any operation or calculation with irrational number results to give irrational numbers. So this is the way we will find out the solution for the numbers to be rational or irrational numbers, and I'll definitely upload a sheet for the calculation so as to find out which number will be rational or irrational. And instead of that, if you have the NCERT app in your phones or laptops, then you can easily find out the exercise. You can have your NCERT book, just solve that part. No need to find out any hard questions and all. There is nothing extra which is required. You can simply do all those questions and that would be sufficient for you to get the solutions for these type of questions that will come into your examinations. And in the next part, what we are going to discuss is the exponential terms exponential terms and properties, we can say. There are very small properties that we have already studied in 8th and 9th class that we will be discussing. And till then, that is all from my side for this topic. Just keep in touch with the channel. Please like and subscribe if you are on this channel for the first time, and also please press the bell icon so that you can get the updates timely. Thank you.